Hello all, welcome to my engineering physics channel. In previous some sessions we have started unit number 1 fundamental of photonics. So today is the last session for this unit 1. So let's start the session. In today's session we are going to discuss attenuation and various factors affecting the attenuation. So let's start the session. So what is a attenuation? Attenuation is nothing but the losses in the signal, which is known as attenuation. So briefly, it can be described as the power loss of an optical signal when the light ray travels through the optical fiber. That is known as attenuation. That means when a light is travel in an optical fiber, there may be some losses of optical signal. So this is known as attenuation. So attenuation of the optical signal is defined as the ratio of optical output power from the fiber of length capital L to the input optical power. So this can be written as P0, which is equals to Pi e raised to minus alpha L. Here P0 is nothing but the output power, Pi is nothing but the input power, and alpha is nothing but the attenuation coefficient. And L is length of optical fiber. So this attenuation coefficient can be written as alpha equals to 10 upon L log of Pi upon P0. Here Pi is input power and P0 is output power. Now this attenuation coefficient can be are of two types, that is intrinsic attenuation and the second one is extrinsic attenuation. So the intrinsic attenuation is due to the impurities present in your material. That means the impurities present in a glass during manufacture causes the intrinsic attenuation. So there are two components in intrinsic attenuation. So when the light signal hits the impurity in the fiber, it may be scattered or absorbed. Based on that, there are two characteristics, that is material absorption and the second one is relay scattering. So material absorption is occurs due to the imperfection and the impurities in the fiber, and this can be reduced by improving the manufacturing processes. Now the second is relay scattering. So due to the impurities, the refractive index is changed and due to which it causes the scattering of light. That means the impurities changes the refractive index and it will cause the scattering of light, which is known as relay scattering. So this relay scattering depends on the wavelength, which can be given as Rs is equals to 1 upon lambda raised to 4. So second attenuation is nothing but the extrinsic attenuation. So this type of attenuation is due to the external materials or the external factors. In this extrinsic attenuation, there is some bending processes. So due to this bending, the strain is produced on the fiber and it affects the refractive index. Due to this refractive index it changes, the critical angle will also change, and that result the total internal reflection, that is TIR, is no longer satisfied. That means as we bend the fiber, the strain is produced in the fiber and it changes the refractive index and it also changes the critical angle, and as the result the total internal reflection is not satisfied. Hence the light traveling in the core can refract and the losses will be occur. So extrinsic attenuation caused by two external factors, that is macro bend and the second one is micro bend. So macro bend is nothing but the large scale bend that is visible and micro bend is nothing but the small scale bend. So this is the two factors affecting attenuation. Now the next point is communication system. So in our communication system, the optical fiber is used. In traditional communication system, the electromagnetic waves or the radio waves for the transmission of the data. In this communication system, we are using the optical fiber to transfer the data. So initially your data has to be converted into optical signal and then your optical signal is again converted into your electrical signal as the output. So this is occurs in this communication system. So if we feed the input data through the transducer, so it will convert one form of the data into another form. That means electrical signal is converted into optical signal, and this optical signal is given to the LED driver circuit, and LED will generate a photon of your input electronic data. and this photon is connected to the fiber connector. Through that, your information in the form of light or the optical signal is transmitted to the photodetector. So this photodetector detects the photons and gives us the electronic signal. And if the strength of the signal is low, the amplifier will be amplify the signal, and this signal is again given to the transducer, and at the end you will get the electronic data as your output. Now the next point is advantages of optical fiber communication system over the conventional communication system. So the first advantage is the optical fiber is low cost. That means the manufacturing cost of fiber is low. That is, this optical fiber is made up of silicon oxide or a silica, and it is most abundant material on the earth. Now the second advantage is small in size. So the cross section of the optical fiber is very less, that is in few hundred of microns, hence the fibers can less bulky. Now the next advantage is lightweight. So as the weight of conventional cable is 1100 kilogram per kilometer, where for fiber cables it reduces to 6 kg per kilometer only. Now the second advantage is flexible and strong. In spite of lightweight, fibers are flexible and strong. Now the next advantage is safe. When a coaxial cables is used, the accidents due to the short circuit may be occurred due to the high voltage, but it can be reduced by using the fiber, as the photons are used for the propagation of signals. Now the next advantage is no crosstalk. As the photons are trapped in a core and cannot leak out, so the chances of the crosstalk is reduced. Now the next advantage is resist to electromagnetic wave and radio frequency waves. As the light is propagating in the form of photons and the photons are electrically neutral, so the signal will not affect the electromagnetic waves and radio waves, so the noise gets reduced. Now the next advantage is wider bandwidth, and a telephonic able to 900 pairs can carry 10,000 of calls at the time, whereas an fiber 1 millimeter area can carry 50,000 of calls at a time. So its bandwidth is wider. Now the last advantage is low attenuation coefficient. So the loss per unit less in very less, that is 4 dB per kilometer. So the loss is reduced when the signal propagates from the fiber. So this is the advantages of optical fiber over a communication system. Now let us discuss some numerical problems. So the first numerical problems they are giving that calculate the numerical aperture of an optical fiber having the refractive index of 1.55 for core and the refractive index of 1.50 for cladding. That means here they are giving the two refractive index, one is for core and second one for cladding. So core refractive index we are denoted as mu1, which is equals to 1.55, and the refractive index of cladding, that is mu2, which is denoted by mu2, which is equals to 1.50. So as we know, the numerical aperture is nothing but the square root of mu1 square minus mu2 square. So we can replace the value of mu1 and mu2, that is square root of 1.55 square minus 1.50 square, and you will get a final answer of 0.39051. So this is the expected numerical aperture. Now the next numerical, calculate the fractional index change for a given optical fiber if the Ri of the core and the cladding is 1.553 and 1.499 respectively. So in this numerical also they are giving the values of refractive index of both core and cladding. So the core refractive index is mu1 equals to 1.553 and the cladding is mu2 is equals to 1.499, and you have to calculate the fractional index. So this fractional index is denoted by the letter del, which is equals to mu1 minus mu2 upon mu1. So after putting all the values of mu1 and mu2, you will get del is equals to 0.03477. Let's discuss the next numerical. Calculate the numerical aperture and hence the acceptance angle for an optical fiber whose core and cladding has a refractive index of 1.59 and 1.40 respectively. So in this numerical, they are giving the refractive index of both core and cladding. So core refractive index is mu1 equals to 1.59 and the refractive index of cladding is 1.40. And we have to calculate the numerical aperture and the acceptance angle. So as we know, the numerical aperture is equals to square root of mu1 square minus mu2 square. So after putting the value, we will get the square root of 1.59 square minus 1.40 square. And the final answer for numerical aperture is nothing but the 0.7537. And the next is acceptance angle. So the formula of acceptance angle is nothing but the theta I max equals to sine inverse of Na. So you have the value of Na, that is 0.7537. So put it down here. So you will get theta max equals to sine inverse 0.7537 and you will get a theta max value which is equals to 448.91 degrees. So this is your acceptance angle. Now the next numerical is a fiber cable has the acceptance angle of 30 degree and the core refractive index is 1.4 and calculate the refractive index of cladding. So they are giving the acceptance angle and the refractive index of core and you have to find the refractive index of cladding. That means they are giving a mu1 and you have to calculate the mu2. So as we know the formula of acceptance angle, that is sine theta I max, which is equals to square root of mu1 square minus mu2 square. So as we know the value of theta I max, that is 30 degree. So put it down here, sine of 30 degree which is equals to square root of, and you have the value of mu1, you have to calculate the mu2. So after putting this value, I can write 1.4 square minus mu2 square. So taking this mu2 to this side, I will get mu2 equals to 1.4 square minus sine square 30, and after calculating this you will get the final value of mu2 which is equals to 1.3072. So this is your refractive index of cladding. So this is all about today's session and all about the unit number 1. So here we have ended the unit number 1. In next session we can start the unit number 2, that is quantum physics. So thank you all. So please like, share and subscribe the videos.